Hello, how you doing? It's Mr. Do the Math here, and today we're going to talk about exponent rules. Right? Basic exponent rules. Let me grab a better marker. All right, and so let's just dive into it. All right, we're going to look at two. We're going to start off with two. We're going to talk about the zero power and the negative exponent. All right, so first things first, we need to know what the exponent is, right? The exponent is synonymous to, the exponent is the sub number, what would be sub? Well, it's the small number above a base, right? The base could be anything. The base could be a letter or a number. So you have the base, and then you have your exponent. Right? So for instance, if the base was 3 and the exponent was 2, right? Base is the big number, the exponent is the little number. The little number tells you how many times this base is going to be multiplied by itself, right? So if it's 2, that means it's going to be 3 times 3, right? If this exponent was 5, it would be 3 times itself 5 times. So it would be 3 times 3 times 3 times 3. Not 15, but 3 times 3 times 3 times 3. So that's like 9, 24, 27, 9, 27, 81. And then, what's that? 243, right? So that's what 3 to the 5th power is, right? So the exponent tells you how many times the base is going to be multiplied by itself, okay? Now, these are special situations. Now, so anytime, here's your rule. Anytime a number or a variable is raised to the 0 power, the answer is 1. Anything raised to the 0 power is 1. Okay? So no matter how big the number is, if it's raised to the 0 power, it's 1. Right? Now, that's it in a nutshell. Anything to the 0 power is 1. Now, negative exponents. Negative exponents, if I had, say, 5 to the negative 1 power, with negative exponents, when you simplify them, this is when I simplify 0 exponents is 1. When I simplify to the negative exponent, the goal is to get rid of that negative, the negative sign, right? So in order to get rid of the negative sign, the whole base and exponent has to go to the denominator, right? Or they have to flip. They become a reciprocal of each other, right? So in this case, 5 to the negative 1 power is going to be 1 over 5. And I can just leave it 1 over 5 because the exponent 1 is understood, okay? What if I had 3 to the negative 5th power, right? 3 to the negative 5th power, to simplify it, you'll just put it over 1. So it'll be put 1 over it, 3 to the 5th power, right? And the same thing and vice versa, right? So if I had 1 to the 3 to the negative 2 power, 1 over 3 to the negative 2 power, to get rid of this negative, I will move it up. So it'll be 3 to the 2nd power. Right? And so that's what happens with negative exponents. When you have a negative exponent, you flip it, right, to get rid of the negative sign. When you have a 0 exponent, it's always 1, okay? Now, let's go into our exponent rules, right? All right. When you multiply numbers, when you multiply similar bases, you add the exponent. So when you multiply anything raised to a power, you add the exponent, right? So if I had n to the 3rd times n to the 4th, the solution is n to the 3 plus 4, which is 7. N to the 7th, right? So this is all in standard form, right? N to the 3rd is in standard form. If I was to expand this, so you understand this is 3 n's, n times n times n. Remember I said the exponent is the base times itself, right? That many times. And then it's going to be n times n times n times n. Right? N to the 3rd times n to the 4th is going to be 3 n's and 4 n's. And so essentially what you're doing is you count how many n's you got. 1, 2, 3, 4, 5, 6, 7. 3 plus 4 is 7. So this is what happens when you multiply variables raised to a power, right? Now, if these variables were numbers, right? So if it's 3 to the second times 3 to the third, the 3's are the bases. Since the bases are the same, you treat it the same way. So it's going to be 2 3's, bop times bop, and bop times bop, bop. That's 5 3's, which is going to be 3 to the 5th power, or 2 plus 3, right? Now, what happens if I divide? So this is the multiplication rule, right? So the multiplication rule is when you multiply, this is like A and B, you add exponents. So it'll be n to the A plus B. All right, let's look at division. So if I had n to the third divided by n to the fourth, you subtract the exponents. So in this case, it'll be n to the 3 minus 4, right? That gives us n to the negative 1. And we just talked about negative exponents. Since it's to the negative 1 power, it'll be 1 over n, right? Now, let's expand it so it makes sense. So this is basically going to be n times n over n times n times n times n, right? You end up with bop, bop, bop. So 3 of those cancel out, and you're left with 1 over n. Just like that. So when you divide variables or numbers or similar numbers, you subtract the exponents. So it'll be n over, let's say n over m to the b a. You'll get, well, let's do this. N and n. It'll be n to the a minus b. Right? So when you divide variables, you subtract the exponents. When you multiply variables, you add the exponents, right? And so like let's look at some more examples. All right, so what if I had negative 4 to the second over negative 4 to the 7th, right? This is division. The bases are the same, negative 4, right? So we're going to subtract the exponents. So it'll be negative 4 to the 2 minus 7. That's going to give us negative 4 to the negative 5th power, right? And to simplify that, we'll just simply put 1 over. So it'll be 1 over negative 4 to the 5th power. Okay? So this is us simplifying our exponents. All right? Let's look at the exponent rule, the power rule, right? When a power is raised to a power, you multiply those exponents. So for instance, if I had a power, so 4 to the 6th power raised to the 3rd power. All right. Now this is not 4 times 6 times 4 times 3. I mean, not 4 to the 6 times 4. This is not this. This is not that. So in this case, you would add. This is not that. This is something different. This is 6 to the 3rd power. Whenever you have a power raised to a power, you multiply. Right? So in this case, it'll be 4 to the 6 times 3. 6 times 3 is 18. So your answer is 4 to the 18th power. All right? Whenever a power is raised to a power, you multiply. So if I had n to the b raised to the a power, it would be n to the a times b. Right? So this is our product rule, quotient rule, power rule. Okay? Now let's make it a little more challenging. All right? So look, what if I had 10 to the 4th times 10 to the negative 6th power? All right? This is just reviewing. This is an example of product, the product property, right? And so what I'm going to do is going to be 10 to the 4 plus negative 6. All right? Same sign, add and keep, different sign, positive, negative, subtract. So you end up with 10 to the negative 2 power. Then from here, you want to just write it properly, right? You want to simplify this correctly. So you can't have a negative exponent, you put it in the denominator. So it'll be 1 over 10 squared. Okay? Let's go a little bit further. Let's look at, we're gonna keep it here. All right. What about this one, guys? What if I had negative 7 to the 0 power? What's that? 1. Good. This simplifies to be 1. What if I have, check this out. What if I had, let's keep, p to the 4th to the 7th, right? P to the 4th to the 7th, all right? Power raised, this is a power one, power raised to a power. So it's gonna be p to the 4 times 7. 4 times 7 is 28, okay? So again, this is pretty much it, right? We're just looking at product, quotient, and power rules, right? When you have a number times a number raised, you have a number raised to a power times a number raised to a power, or variable raised to a power times a variable raised to a power. Again, the same variable, so the bases have to be the same, then you add the exponents, right? When you have numbers divided by, you subtract, quotient. And then if a power is raised to a power, you multiply. So what if I, look at this one. If I had n to the 3rd times m to the 3rd, these are different bases. The bases got to be the same. Since these bases are different, the answer is n to the 3rd, m to the 3rd. You can't do anything with it, okay? But let's say I had n to the 3rd, m to the 3rd raised to the 2nd power, right? In this case, you're going to distribute this 2nd power to everybody. So it's going to be n to the 3rd times 2 and m to the 3rd times 2. That's going to give you n to the 6th, m to the 6th. Okay? You feel me? And that's pretty much it. Like, these were the rules, and I think this is something that you may have seen in middle school, or you will see in middle school, depending on who's watching this video. But take this to heart. The bases must be the same. And when you're multiplying same bases, whether they be numbers or letters, you add the exponents. When you divide, you subtract the exponents. And then when you raise a power to a power, you multiply the exponents, right? Now, keep in mind, before I go, keep in mind when you're dividing. So for instance, if I have 5x to the 3rd over 10x to the 3rd, well, let's make it a number. 10x squared, right? This is simple mathematics right here. This is 5 divided by 10, right? So you can simplify this by changing 5 and 10. You divide 5 by 5 and 10 by 5. You only get 1/2. And then from here, you do the quotient rule, right? So it'll be 3 minus 2, right? So you end up with 1/2 x, because 3 minus 2 is 1. This is that, okay? All right, so I hope this gave you more clarity or explained to you the beginning of quotient or exponent rules. If you have any more questions, comment below. Mr. Do the Math out.